Aloha, this is Elizabeth Tippett, and for Psychology 100, the wave experiment, WaveLab. So it wants me to discuss if the waves are being reflected, and we'll start with the first one that's in the middle. And as you can see, all the waves went out to each side, and then they slowly came out, but they lost their energy before they could really gain, before they could have huge momentum. And maybe it's because I'm using a penny instead of another pebble or something. Okay, and then doing it to the side. Yeah, you could see it bounced off of this wall quicker and came back, and then it reflected off of this and off of the sides at a longer length, and now in the corner. And you could see that it went in all directions, bouncing, and then it's coming back. So it is reflecting. The second question was, are the waves interfering with each other? Yeah, they were interfering, because when I dropped it right here, the waves go out, and then the ones that came this way reflected that way, and the ones that came this way reflected that way. And so they did end up interfering with each other, which happened for, this one as well, where they come and then they interfered by coming back. And then comparing the directions when we saw the wave moving and reflecting when we dropped it in the middle and with the side. As you could see, like this one, it just kind of went out. And although it did come back in and the waves interfered with each other in the center, it didn't have as much. But in the corner, it has a lot more interference because it reflects so much more, and each reflective wave met with each other but kept going the way they're supposed to. And it asks, how does this demonstrate that the angle of incident equals the angle of reflection? Well, if you look carefully, you can see that the wave that reflected here, equally reflected in the equal angle, and so that is how it equals the angle of incidence for the angle of reflection. Mahalo.